Haha, did I scare you? I just wanted to say hi and welcome to your lesson. We are going to go over properties of exponents today, lesson 1.8. And yes, you're going to see a lot of stuff on this. And no, you're not going to have to do it when you actually work your problems out. I'm just showing you how it works. Okay, so first thing we're going to do is multiplication and division when we have exponents. So I wrote out this example. Let's say you have x to the third power times x to the second power. That would be x times x times x times x times x. And notice that you've got 5 of them, so that's x to the fifth. Well, the simplest way to do it, to show you that, is it really turns out to be x to the 3 plus 2. You can add the powers, which is x to the fifth. So when you are multiplying, you can just add those powers together. Well, what if you have a negative exponent, like right here, 5 to the fifth? I'm sorry, good grief. Sorry about that, I made a boo-boo. B to the fifth and b to the negative second. So what that looks like, and I'm just showing you what this looks like, so don't freak out about it. I'm showing you how this theorem works. That means you have 5 b's and you're multiplying it by 1 over b times b. Remember the other day when we said that's what this is equal to, b to the negative 2? Well, if I associate some of my b's together, like this, now I have 3 b's over here and I've got 2 over here over the 2b that are in the denominator. Remember, I'm just showing you how this works. Well, that reduces to 1, right? So it's b times b times b. That's the identity property because that reduces to 1. And it ends up being b cubed. So in essence, you can just subtract those exponents. So I showed you how this was the original problem. You can just say b to the 5 minus 2, which is b cubed. There's a happy face. This is all you'll be doing. I'm just showing you how it works right here. So let's do an example. All right, let me get my favorite color, ink. Yes, this pretty blue is my favorite color. So when we do this example, we know we can just add them together. This turns out being 8 to the negative 3 plus 7, which is 8 to the fourth. And if we work that out, it is 4,096. Now this looks a little scary because there's a whole bunch of stuff, but we're just going to do it the same way. First, let's distribute this through. And let's say 5 times 6, that's 30. And I have an x to the m plus an x to the 7. See that? And then I have y to the n plus a y that was to the fourth. So I can just add those exponents right there. Does everybody see how that works? I hope so. You hang on just a second. I lost my place right here. So let me go back and look. Yes. So, and that's, you reduced it, you distributed it through, and this is what it looks like. Very simple, even though there looks like there's a lot of stuff here. All right, let's move on down. What if we have division? Take a look at what I've written in red. What if you have 8 to the fifth divided by 8 to the third? This is what it means, and I know this is a lot of stuff. This is not what you're going to have to do. It means 8 times 8 times 8 times 8 times 8 divided by 8 times 8 times 8, which if those 3 of those cancel, it becomes 8 squared. So really, when you see division here, you can just subtract the exponents. 8 to the fifth minus the 3 that was down here is 8 squared. So yay, this is all we have to do. So let's take a look at a couple examples of those. The example 1 I went ahead and did for you just because it's pretty simple. Since it's division, I can say 9 to the negative 2, take away the 5. And negative 2 take away 5 is negative 7, so it's 9 to the negative 7th, which we learned the other day we have to divide this by 10. So it's 1 over 9 to the 7th. 1 over 9 to the 7th. So let's work this one out. This one looks a little bit longer, so we can work it out together. All right, let's just spread this apart to help us see. Now, no, you don't have to do this if you can see it without spreading it apart, but that's what I'm going to do just to show you. This ends up being 16 over negative 8 times x to the 4th over x to the 3rd. I'm just separating this to help us see it just a little bit better. Now when we work this out, we've learned that all we have to do is subtract when we get to the exponent. So first, 16 divided by negative 8 is negative 2. And then if I subtract my exponents, 4 take away 3, that leaves us 1x. 7 take away 9 leaves us a negative 2y. Now, since I know this negative 2y really means 1 over y to the y squared, I can turn this into negative 2x over y squared. And that's how that simplifies after we divide. All right, what if I have a bunch of powers raised to powers? Let's take a look at this example. Now, I wrote this out just so you could see it. 5 squared raised to the 4th power. This is what in essence that you're doing. You're doing 5 squared times 5 squared times 5 squared times 5 squared, which we said earlier means 5 to 2 times 4, which is 5 to the 8th. Or what if you have a negative exponent? And I went ahead and wrote this out for you. Since it's the negative exponent, we know that it's 1 over 8 squared, and I have to have 3 of those. So 1 over 8 squared times 1 over 8 squared times 1 over 8 squared equals 1 over 8 to the 6th, which if we put it back up is 8 to the negative 6. But look what we could have just done. We could say negative 2 times 3. Just like up here we did 2 times 4. But this all right here, Tana and Jesse, because I know y'all worry about all this. Do I have to do all this stuff? No, I'm just showing you how it works. How this right here, when we see that we just have to multiply, how it works out. Okay, so negative 2 times 3 is negative 6. So we get the same thing. So let's do a couple examples with this. So I wrote 3 to the 5th raised to the 7th power, and I know that now I can just multiply 3 to the 5 times 7 power, which is 3 to the 35th power, which is probably a big number. I'm not going to work that out right now. Then let's do this one right here. X to the negative 5 raised to the 4th power. And we just said that we could say x to the negative 5 times 4, which is x to the negative 20. And we know that if we have a negative power, we need to put it in the denominator. This is equal to 1 over x to the 20th power. Ha! Isn't that nice to be able to do it that simple way? Alright, what if there are several factors inside the parentheses? I'm going to show you a couple of these, and pretty much you do what you've learned already. It shouldn't look too different. Alright, so let's take a look at this one. 3x squared y to the negative 2, all of that raised to the 3rd power. Alright, so let's do it all. Now that'd be 3 cubed times x, and we just said we could multiply that, right? 3 times 2, which is x to the 6. Now we're going to do our y's. Negative 2 times 3, that's negative 6. So let's work that out. 3 cubed, I know off the top of my head, that's 27. X to the 6, and because y is to the negative 6, I know that that's going to be in the denominator and turn positive in the denominator. So there's our final answer. Alright, let's take a look at this one. 5 to the 5th divided by 3 to the 4th. All of that cubed. How is that going to work out? Well, here's what it looks like. If you do what we said we can do, you know that's going to be 5 to the 5 times 3, which is 15th, and 3 to the 4 times 3, which is the 12th. Ha! That was simple. All right. I put another one in here that may be a little more scarier. Hopefully not. Is that a word? More scarier? I don't think that's right. Maybe more scary? Whatever. Anyway, it just has a bunch of stuff in there. So what we need to do is, let me kind of show you first that this is what it will look like. This is really what we're doing. Just an extra step in here. Don't worry about it. I'm showing you that we're raising all that to the 5th power, and we're raising this in the bottom to the 5th power as well, right? All right, so let's work all this out. Shoo, this is going to be a lot. We've got 2 to the 5th, and we know that we can say x to the 3 times 5. That's going to be x to the 15th. Y over here to the negative 2 times 5, which is negative 10. Now let's do the denominator. That's 3 to the 5th. Y to the 4 times 5 is y to the 20th. And then we learned that we can fix this. Let's see. Let's do some reducing here. Does that sound good? Let's do 2 to the 5th. I'm going to draw this like this. I'm going to leave my 3 to the 5th down here. I don't have any x's in the denominator, so that's going to stay x to the 15th. But I have some y's in the denominator, and we said that we would subtract them, right? So negative 10 we have in the top, and we have 20 in the bottom. Would that end up being, I'm going to bring this one down because it's negative and add it to the 20, y to the 30th power. Shoo, mercy sakes. All right, let's go ahead and work out these. So 2 to the 5th, very quickly, is 32. X to the 15th. And 3 to the 5th is 243. Y to the 30th. And if I want to bring this up into the numerator, I know that I can say, this almost didn't give myself enough room, 32 over 243. This is x to the 15th. And if I bring it back up, it's y to the negative 30. Alright? I know that's a lot of stuff, but you're just doing these simple things that we've talked about up here. Alright? So let's move on down. The last thing I want to remind you of is your order of operations, because we see a lot of parentheses and exponents now. Your order of operations, how you do your math, is you do anything in the parentheses first, then you work with your exponents, then you multiply, then divide, then you add, then you subtract. And the easy way to remember that is, please excuse my dear Aunt Sally. I hope you enjoyed your lesson, and we'll do some more work like this tomorrow. Goodbye.